All right, so welcome. My name is Tom Delora. I'm the newest technical solution specialist at CAD Dimensions. Thought we'd mix it up and give you guys a chance to hear somebody other than Kevin and Lars. Being the new guy, this is my first lunch and learn. So because of that, I ask that you provide me any feedback either during this presentation or afterwards. My email will be the last slide in this presentation. Hopefully you guys find this is some good information. Just to get started, I'd like to send out a poll and see if this is anyone else's first lunch and learn. All right, it looks like a lot more of you are more veteran than I am, so please, any tips or tricks as we go through this, please let me know. All right, today's lunch and learn is the topic of mirroring. We will discuss the uses of mirroring in the various areas of SolidWorks, so sketches, parts, assemblies, and we'll look at some sheet metal. Just one more quick poll before we get started here. Looking for everyone's comfort level in with using mirroring. Either you didn't know that there was a mirror option, you're aware of the option but don't really use it, you're fairly confident when designing using mirroring, and if you use it all the time but hoping for that nice tip and trick that you could get out of today. All right, we got some confident people out there. So it's 68% people are fairly confident. About a quarter of you are aware of the option but don't use it. And about 9% is probably more proficient than I am, but hopefully I can teach you some nice tricks here. All right, so getting started here. Here's what I'd like to touch base on, just some background of mirroring, the uses of mirroring, as I said, across sketches, parts, sheet metal, and then inside of assemblies. And then we'll wrap up with the advantages of using mirroring. So mirror copies is a selected feature or all features and then mirroring them out about a plane or a face. So it's really an easy way to create symmetry within a part. SolidWorks also allows the ability to propagate colors, textures, and cosmetic thread in mirrored features. And we'll go through the propagate visual properties option in the property manager. And then mirroring is extremely useful for parts and assemblies that are symmetric. It enables the designer to save time reproducing identical faces, features, and parts. So as we go through, we'll see where symmetry applies, and we'll look at how do you take advantage of using that symmetry. So starting off, we'll go through sketches and the 3 opportunities to use mirroring within the sketch. So we'll just start with a new part in SolidWorks. I'm using SolidWorks 2014 beta. 2014 is coming out next month, so if features are here that you don't use, I might be a little ahead of the curve here, so I apologize for that. But we'll start with a sketch on the top plane just to show what some of the sketch features are. So we got a new part. We're going to create a sketch. So when using mirroring, you either need a center line. When you're mirroring a part, you'll need a face of the part. So we'll start here with a center line, and we're just going to make it a construction geometry. I'm going to keep this one real simple, and we'll just make a couple of circles. And these will be our sketch to mirror across the center line. So the first way to mirror is to use mirror entities. When we do this one, we'll select the button up on the top. We'll select the entities we'd like to mirror, and then we'll mirror them about a line. As you can see in the preview, our identical sketch is going to mirror over the line. what we're doing here is making a copy. We can also choose to deselect copy, and what that does is just flips our sketch over the center line. When we create the copy onto the other side using the mirror entities, and we do select copy, we'll create two versions of the same sketch. So that is using the mirror entities. As you can see here, these two are tied together. Each is a separate entity. Hold on a second, please. Sorry about that. So these entities are tied together via a sketch relation. So as you can see here, when we turn on our sketch relations, each sketch feature is tied together through the center line. So object 0 is the center point of the circle. It's tied to the center line and then tied to the opposite hand version. As these move, they move together. If we delete this relationship, we are no longer mirrored across the center line. Oh, sorry. We delete this relationship as well. We're no longer mirrored across the center line, and these two are no longer have that relationship. In order to turn that relationship back on, do control select of your sketch, your center line, and your opposite hand, and you can add a symmetrical relationship which ties these two back together. Another interesting point here is if we remove our horizontal relationship of this line, vertical relationship of this line, we can see that our mirror is always about the center line. So as we move this, our opposite hand image is going to follow. All right. So that's some pretty basic stuff. Just a refresher on how mirroring works in sketching. We can also do dynamic mirroring, which if you know you have a symmetric part, can save you a lot of time while making a sketch. So in order to create the same sketch we just made, sorry about that, it was from the front. We will create the same sketch that we just made. There we go. And this time with dynamic mirroring on. So when we have dynamic mirroring on, you can see that these two symmetry lines are added to the top and the bottom. This just shows you that your center line is now dynamic. So as we add a circle here, it'll automatically mirror across to the other side of the circle. Same with this. When we hit escape and leave our dynamic mirror, as we add geometry, we will no longer see it mirrored across to the other side. Let's just get rid of these last couple circles. Another interesting point here is when you're doing any type of mirror, even if it's dynamic or a mirrored entity, it only allows for the creation, the mirror only allows for the creation of geometry. So as I add all this stuff and I go to my trim entity, you'll notice that while I trim on the left side, it is not mirroring across. We still have our dynamic mirror on. I can still add geometry and it will mirror across. It's just the deletion of geometry does not get mirrored. It's only the creation of geometry. So with that, let's get rid of these items. Same rules apply with dynamic mirror on with your center line. Turn this off. It will be able to move. Also, while we're here, let's put our vertical relationship. We can add some dimensions to this because right now our sketch is not fully defined. So like this one, new feature in 2014, your first dimension will not change the scale of your picture. So just a little preview there. Like this one, we'll make this 0.5. We'll give ourselves the height from the origin of 1. So right now our sketch is fully defined. And we only had to define the sketch on one side of our center line. So by fully defining the left side, we also fully define the right side. I can no longer drag this, it no longer follows. I can still, if I remove my center line, or my horizontal, vertical line, we no longer are fully confined, and we can move this about again. Make that vertical, and we're fully defined. Dimensions can be applied to either side of the center line. So if I remove this 1-inch dimension here and apply it to the right side, so the mirrored side, we again contain a fully defined sketch. One more thing, if we get rid of our center line here, turn it off. So we no longer have symmetry amongst these. I mentioned earlier that you can add a symmetric relationship. You can only add a symmetric relationship. So before I click the two geometry and the center line, I no longer get the option here. You can only create a symmetric relationship about a center line. So using construction geometry for your center line. So if I try to do that again, geometry, center line, geometry, I am able to get the symmetric relationship back. And now these two are tied together. Also, our dimensions and our relationships, when we deleted the center line, are also removed from the mirror. So unless we go ahead and add our own dimensions over here again, or we apply our symmetry relationship, we won't be able to control these using a mirror. All right, I think that's all I have to show about sketching. Do we have any questions coming out of that? All right, no hands. So we'll leave that. All right. So we went through mirroring entities, dynamic mirroring, and symmetric relationships. All right. Our next part in mirroring, we'll look at parts and the many options that come with mirroring a component. So we'll look at mirror features, bodies to mirror, faces to mirror, and then we'll look at a sheet metal part and show how mirroring works there. So going back into SolidWorks, we have this assembly, partially completed assembly. This is for a table saw, so it's a fence to protect your hands and give you a straight edge while cutting wood off the table. So we have our top fence, we have a bottom fence, we have a set screw to tighten this into place. We have a sheet metal clip, and then we have an aluminum base that ties into the to your tabletop. So looking at this, it is an assembly. It is not attached. It is just a conglomeration of different parts that we will look at. So the first part we want to look at is this bottom base, and we'll see how it was created because it's a very symmetrical part, and we want to look at how mirroring was used to create that part. So we'll come in here and we will open up our lower fence. So we'll use the rollback bar to step through the creation of this part. So the first step was a simple extrusion. Now that I look at it, and this is also symmetrical, so a mirror could have been used, but it was chosen not to. We do a revolve cut just to kind of smooth out that surface, apply a fillet. Then we make our slide rail, which was used using a mirror. So we first make our slide rail on the left side. We had a simple hole to start. We had a second hole to go through. And then we pattern that hole to make a second copy of it. So this one wasn't a mirror, it was used, a pattern was used to follow it along the x-axis. We then mirror all three features, or it's really 1, 2, 3, 4 features over to the other side. So it's the initial hole, the deeper hole, the slide rail, and the pattern all get mirrored across this right axis to the other side. So I just said that we had 4 features that got mirrored across, but when we open up our mirror, we see that it goes around a right plane, but the features that were used are only 2. All we see is the extrusion for the slide rail, and we see the pattern that was brought over. So when you're using a mirror and you select the child of a parent feature, that child will bring with it its parent and all characteristics that, or all features that created that parent. So to take this a step further, if we step back into our pattern, and we see that we created 2 holes using the pattern, and we add a 3rd hole to this. When we accept this, we'll see that the mirror automatically pulls the third hole with it. And when we go back into our mirror feature, we see that we only are selecting 2 features. We got our pattern, and we're only selecting the second hole of the pattern. So anything associated with this pattern comes, and the extrusion cut comes over. So that's a nice feature to have, that when mirroring, if you do have to update anything, you can always come back to your feature created before the mirror, add or take away, and it will automatically be updated for you. So let's tweak it back to the 2 holes we needed. We'll accept it, and just like that, we're back to where we were. So scrolling back through this part, we extrude a little front plate using a surface. We fillet the whole top. So now we try to smooth out our rail and give it a new material that comes across. So it's just a little square that goes all the way through the path. And inside the square, we're using polished aluminum. So we'll come back to that when we mirror some features and we use the propagate features. So coming back through, we used the hole wizard on the right-hand side of this part to create 2 holes. And then we mirror those holes to the left-hand side of the part, just going across the right plane. Looking at that, same way we did before, it's a feature to mirror. We take the tapped hole, which is 2 holes, we go right across the right plane. So then going further, we add an extrude down, which will tie into our base plate, and then we cut it to fit into our base plate. So as I was talking, we used a propagate features. So in order to get this extrusion down to the other side, we just use a mirror across the right plane. And looking at these 2 pieces, they're using polished steel. So as we open up this feature, we can see that we selected propagate visual properties. And this feature is both the boss extrude for the extrusion coming down and the cut extrude. If we did not bring the cut extrude with us, we would just get the initial part, which is this full base extrusion. However, we do want the cut extrusion, so we'll come back here and select it. And now we're back to our desired geometry. But like I was saying, we use the propagate feature off our initial part. If we turn off propagate feature, or I'm sorry, propagate visual properties, and we can see that this one's polished steel and this one is back to our polished brass, which is the top level visual property of this part. So using the propagate feature, you're able to take any characteristics associated with what you want to mirror and actually bring it across the plane that you're mirroring about. So there you have it. One more thing to show is some order of operations. So if we want to mirror this part to make a full circle here, we would go ahead and select under our Features tab, select Mirror. We want to go across this front face, and we want to select pretty much all features that have been associated with this one, starting first with this extrusion cut. So we select the extrusion cut, or I'm sorry, the cut revolve, and we select it. So it looks like nothing happens. We get a mirror feature. SolidWorks is tracking it. We see that it happened, propagate our visual properties, but nothing comes across. If we do another mirror and we take our initial extrude and we still go against the front plane, our feature is extrude. We bring it in. We get the solid part without a cut. So order of operations, just like any other SolidWorks model, is important during mirroring. If we bring our extrusion before our cut, it'll mirror the extrusion first, and then it will remove that material using a mirror feature. So we can continue to try to create this full part by mirroring every feature in this. So everything wants to go over the front plane. And then we want to mirror this cut. We want to mirror this hole. Interesting part about selecting this hole, which is a pattern of a feature. It's a mirror of a pattern of a feature. So this was the initial hole. It was then patterned. It was then mirrored across the right plane and brought over here. By selecting just this hole, we get all four features that come across this mirror. So that's kind of a nice thing to have when selecting features. So we can continue selecting feature after feature. We'll get our fillet over. We'll get this hole will come over. Pretty much it's selection after selection after selection. And when I think I have everything, I'll hit OK. And by trying to select everything, we get an error. Unable to create instances for the pattern. So pretty much SolidWorks is telling me I'm selecting too much here. And I'm sure I missed something, so I missed this front panel. Stuff gets missed when you try to select multiple features for a mirror. Instead, hidden in our mirror option is a bodies to mirror selection. So let's go back into features, we'll clear the selection, and we'll try to start fresh. We'll get rid of our previous mirrors. So this is our original part. We still want to mirror across the front. So come in here, we'll drop down the bodies to mirror. We're still going across this front plane. And then with one button click, it selects the entire body with all features that we've created. And just with 3 clicks, we can completely mirror this body across the front plane to make one solid feature. A couple options that come with mirroring body. There we go. You can merge the solids. So this will take 2 bodies and merge them into one. If we do not select that, when we look up here at solid bodies, we'll have our original part and our mirrored part, and we can save these off as separate parts. When we merge them, we're back down to one solid body, which is both sides of the mirror. Again, we get to propagate visual properties. So this will take all individual properties and bring them over. So like you can see on our bottom extrude, where we were once polished steel, when we don't have that clicked, we go back to our brushed brass. Knit surfaces is when you're dealing with just surfaces. If you're trying to create a solid by using a mirror, and you click knit surfaces, that'll try to attach all corners that are mirrored together. So for this part, I really only need the one side, so we'll delete that last mirror. I'm happy with what we did here. We added this, so I can save it, and we'll go back into our assembly. So now we have an update here. Looking at the assembly, I have this base that goes onto the table that requires a really interesting cut. And when I look at it, I only have it on one side. So this part, when mated together, will not fit on this side. I have too much interference. So we're going to open up this and try to get this feature nearer to the other side. When I open it up, let's just walk through how this part was created. So pretty simple 180 revolve around the around a circle. Kind of an interesting sketch, but nothing too extraordinary. We then use the split line. So split line takes a sketch on a plane. So we have this mushroom-shaped sketch, and then it reflects it up to a surface. So for this instance, we're using these two surfaces. Once it has those surfaces, it'll project that sketch onto that surface. After that, we actually create a surface. So we take that sketch, we offset it 0, and then we have a surface that we can start to play with. And then a cut thicken drops us down, it's 2 millimeters, or 2 inches here, 0.2 inches. Drops it into the surface 0.2 inches. So nothing here, because it's a rounded surface, is really flush. We go down 0.2 inches all around, but this is certainly not a flat surface. Finally, we just do a fillet to make it look all nice. So what I want to do, I want to bring this feature over to this other side. So we'll go back up here to our mirror. We're going to mirror it about the right plane. And we're going to try to select the split line, the surface offset, the cut thicken, and the fillets. When I try to hit accept, even though I get my partial preview, when I do a full preview, I lose it. We get rebuild errors, and the surface cannot be thickened. So what we're running into is SolidWorks is trying to do a lot of math to figure out this geometry of this dimpled feature here. Between the split line, the added surface, the cut thicken, and then all the fillets, it's just a lot of geometry to try to duplicate over. So what SolidWorks is, it just can't figure out that new surface. So instead of trying to mirror the feature, we can select all the faces of this dimple and try to mirror them across the right axis, or the right plane. So by selecting the features, the mirror box, and then just highlighting all our faces inside this dimple, you got to make sure you get them all. We end up getting our full preview that comes across to this other side. We can accept it, and with that, all new faces are created into this part. So with that, I think I'm happy on this part. We'll save it. And with that, it gets updated into our assembly. So now we can add a new mate here. And with that, we're back in business as far as this assembly goes. So one more part here is our sheet metal clip that was created using mirroring. Don't want to make it. So let's go into this one and see what we're dealing with on this. Open up the sheet metal part. So clearly we have some mirroring that was done to use this part. It is symmetrical. All right. So we'll back up. We're using a sheet metal part. We start with this flange that has a slot cut out in it. In order to do a mirror in sheet metal, you have to have both faces available once you start doing some sheet metal properties. So we have an edge flange that comes up and just gives it a 90-degree bend, and then we hem it back over to act as our clip. So when we do this mirror, it's across the right plane. So using symmetry while doing sheet metal parts is pretty important, because what we couldn't have done here is if we back this up, we can't take this whole part and try to mirror it against each other. So if I do a mirror here, and I want to go off this face, and then my features are this base, this can't be mirrored individually. It can be mirrored using our body and select the whole thing and do it that way. But a flat piece of sheet metal can't be mirrored across a plane or a face. Just delete that. The following feature types can be mirrored in sheet metal, and that's an edge flange, a miter flange, a hem, a base flange or a tab, and a closed corner. So all your typical sheet metal features can be mirrored like this. It's just this base piece is really going to be your difficult feature to try to mirror. So you have to do that separately, and then you can bring all your other features in with you. So after we mirror, we can still flatten our pattern. We'll just unsuppress that. And we see that all our bends are still in the sheet metal part, and they're mirrored correctly across to the other side. So that's what we have for sheet metal. I'm happy with this part. Save it. Go back to our assembly. All right, I think that's what I have for part mirroring. Hop back into our PowerPoint real quick. We covered mirror features, we covered mirror bodies, and then we covered mirror faces in that base plate, and we just looked at sheet metal using the clip. So now we're into our fence assembly, and we're going to look at mirroring parts, creating opposite hand parts, and dissolving mirrored features. Back into SolidWorks. So looking at this part, clearly we're only completed one side. We just have this side, and we need to bring everything over here. Because the idea here is that we have a fence that protects the operator from the saw, which would be over here. But it should be fully customizable. They want this here and the right side at a different degree. They should be able to customize that to allow for a unique opening in the middle. So let's start with an easy part to mirror, and this little set screw, which will end up over here. So up in your top menu, I believe this is standard, but if you do need to add it, you can add it into your top menu. So we're going to go into here and feature or mirror components. Just like mirroring a feature, when you mirror a component, which is a part inside an assembly, you still have to select which plane you're going across. So for this one, we'll use the right plane. And then you choose your components to mirror. So for this one, we're going to select our knob. So when I first used mirroring, I was kind of I accepted SolidWorks for what it was. I would trust it, and I would select my green arrow. And with that, my part ended up where I thought it should be. These were mirrored together. They acted in unison as a mirror. They're in the same hole. They had the same mates. Everything was happy. So as I dug into mirroring more, I realized I was just kind of getting lucky before. If we go back into this property, we'll realize that this is just the first step of mirroring components. There's a next arrow up here that allows you to see more. So when we select more, we then get a preview, where before we did not have a preview. We were just kind of going on dumb luck. We'll get our preview. We can zoom into it. So this next menu allows us to choose orientations of our mirrored part. So our first orientation looked pretty good, which is why we got lucky when I hit the green arrow. As we reorientate this part, we'll try to find a fit for this mirror as it flips across all axes. So we get 4 different orientations. Because this part is symmetrical along this face or along this line, two of the 4 orientations are going to be identical. So 1 and 3 is the same, and 2 and 4 is the same, just for this part because of the symmetry. We can also change the center of mass, change the mirror type between the center of mass and bounding box center. Because this is the same, so when we look back at component 2, our center of mass and our bounding box are completely different because it's so top heavy here. So a couple different options to play with in case you have a mirrored part that isn't fitting correctly into an assembly. So we will take our simple orientation and be happy with it, and we're good to go. Our next feature here, or our next part here, is a little more difficult. It's not symmetrical, and it's not, we'll look at it when we try to mirror. So we do have a question. So we have a question coming in. How do you adjust the colorization of the mirrored part when you're choosing the reorientation? It's nice trans purple on your screen. It's very faint when I do it. So that is, I believe it is a setting, and I'm just not sure where it's located. So let's see if it's something that we can do inside the feature. Our orientation comes across as purple. There's no feature here. To save time, I will get back to you, John. Thanks for the question. But I believe it is in the setting, just like when selecting something, you change the color from blue to green. It's one of those settings. But I'll follow up with you after this, after I do a little bit of digging. All right, so we mirrored our part. Now we want to mirror our top fence over to the other side and make sure that it stays inside the track. So we're going back up to mirror components. We're going to stay going across the right plane. And now our components, we want to bring over our top on their little sheet metal clip here. So we'll hit our next arrow now that we're aware of it. And we'll look at what some of the options SolidWorks gives us. So our first option, if we just hit the green arrow like before, does not get us as lucky. We're not in our track. We're backwards. Our sheet metal clip did not come with it. We're kind of out of sorts here. So let's try again. We'll use our next arrow, and we'll look at our upper fence first. So we know our first orientation doesn't work. Let's try our second orientation. Second orientation just kind of translates our initial part. So still not what we want. If we go to our third orientation, we flip it upside down, nowhere near our track, nowhere near what we want. And our fourth orientation, also upside down, also not in the track, still not what we want. If we try to change our center of mass, drops it a little, we still have no orientation that fits our need. So what SolidWorks did in 2012 is give us this nice option to create an opposite hand version. When we select this, our faded purple turns to faded pink, and we get an opposite hand version symbol up here. So what this does is pretty much mirrors every dimension created in the initial part and puts it across the plane. What this means is we no longer have an identical part that was just mirrored. So like this one, for the knob, we save time by mirroring. Instead of inserting a new knob, reapplying all the mates, and we were just able to drop it in. For this one though, if we tried to insert another upper fence, we wouldn't be able to mate it in such a way as our desired result. So creating an opposite hand version of this allows us to meet all our geometry and meet our design needs. When we select create opposite hand version, another next arrow becomes available. So now what SolidWorks wants us to do is, because it created a new part for us, it wants us to identify this part. So right now we're mirroring our mirror upper fence right hand version. SolidWorks allows us to either make a new configuration of this part inside the existing upper fence part file, or we can create a new file by either adding a prefix, a suffix, or custom. So we'll come in here and make it a custom part. So upper fence right hand will now become upper fence left hand. This button allows us to place the files into our own folder that we choose. If we keep it deselected, it'll drop it into whichever folder the right hand part already lives in. So I'm okay with that option. So again, we have another next arrow for this new part. The final selection in the mirror component menu is which metadata do we want to transfer with this new part that we didn't create, SolidWorks created for us. So we can select the solid bodies that come with it, the surface bodies, the axes, the planes, cosmetic threads, absorbed sketches, unabsorbed sketches, custom properties, coordinate systems, model dimensions, and whole wizard data. So this is a lot of data that can come with this file. If you're worried about file size, you can make a dumb solid and select none of these options, and all you'll get is a dumb solid over here that you cannot edit. If you bring over all the options, because this is a separate part, you can start moving your rims that are here. You can start editing your right or your left-hand version to look different. So we'll keep it simple. We'll just select these top 4 options here. I created this part in millimeters and my assembly is in inches, so I just want to change the new part to match the units that I'm using here. So now we have our desired assembly. However, as I was mentioning before, I want the left hand and the right hand of the upper fence to be unique to each other. So right now, because they're a mirror, they're going to translate at the same distance because they're mirrored over this right fence. So another feature that you can use in SolidWorks is you can select your mirror component, you right-click, and you can dissolve the mirror component feature. So right now, you're going to tell SolidWorks that yes, I like this part, but I no longer want it mirrored to this. I want it to be a free part. So once it's like that, you're free to remate this, and it will no longer have the tie that we had before about this mirror. So we'll throw a couple mates in, this top plane and this bottom. go. Lower fence, upper fence. We want those coincident. We're good there. And then we want this inside face made with this back face. And we're good there. So now we have a part that is unique. The operator can adjust this and set it, and the operator can adjust this and set it. One pop-up that came up when I removed the association. Oh, actually, another part here. When we deassociated it, or when we dissolved that mirror, we no longer have a mirror component. We now have an upper fence left hand, which was the part we created, and a separate metal clip. So when we remove that mirror property, it's no longer identified as a mirrored component. It gets its own part numbers back. I just want to go back a couple steps to where we have that mirrored component back. So we have mirror component 2, which is our sheet metal and our upper fence. I was asked a question that I said yes to earlier. Do you want to recreate mates in the top level assembly after dissolving mirrored component feature? I had selected yes, and you notice that my sheet metal part stayed with me. If I select no, I deassociate all mates that were associated or that came over with this mirror. So now I'd have to remate my sheet metal to my upper fence and my upper fence too. So if you have a complicated part that you just want right-hand version for and you're going to use them elsewhere, you can hit no when you dissolve that mirrored feature. All right, we have another question here. Does mirroring sketches, parts, or components result in a smaller file size compared to copying or patterning? Is it basically the same either way? So mirroring a sketch will reduce your file size because it's less math that SolidWorks is doing. When you mirror a component, it depends on the selection that you bring over with your mirror. So like I said, if you want a dumb solid, you're definitely going to reduce your file size because it's bringing none of the smarts that come with that file. If you select everything, including your axes, your properties, your material properties, everything like that, you're pretty much adding another feature into your part. So it would be like creating a right-hand version and inserting it into your part. So it's, for the same file size, it's considerably less clicks to use a mirror. And then if you do want a dumb solid, you would have a smaller part or a smaller assembly file. All right, so let's just jump back into this. For assemblies, we talked about mirroring parts. We created an opposite hand part, and then we generated a unique part based on that opposite hand, and we dissolved mirrored features to be able to float our opposite hand parts. Just a quick summary here. Some of the advantages of mirroring is symmetric parts require half the geometry to be sketched or generated. So if you're worried about button clicks and dragging lines in geometry while sketching, a mirror is a good way to take a symmetrical part and pretty much cut those button clicks in half. Changes to the original feature migrate to the mirrored featured or parts. So like when we were creating those holes, I used the pattern, or I mirrored a pattern over. As I changed that pattern, the mirror was updated with that single change. So again, having a copy of something that's a pure copy of that parent allows you to update the parent and the children get mirrored and changed with it. And finally, it's a heck of a lot easier to create a left-hand or right-hand version of a part in assembly than going in, recreating a sketch, recreating a part which has exactly inverse dimensions to your original part. So with that, that's pretty much all I had to show you today about mirroring. Again, my name's Tom DeLaura. and my email is there, and my phone number with extensions there. We have a question coming in. How are mirrored components shown in the BOM if not dissolved? So for our knob that we used, when we create a BOM based on that, it would come up as a quantity of 2. And then for our mirrored component, that was a right-hand version. Because SolidWorks made us rename that with either a suffix, prefix, or a unique name, they would come up as 2 different parts. So our fence would come up as a single left-hand part and a single right-hand part for a bill of materials. Do we have any other questions? All right, I'm not seeing any other questions. I'd like to thank you for sticking with me for my first Lunch and Learn. And like I said at the beginning, any insight is appreciated, so please send me feedback.